Assalamu alaikum. Good morning. Today we are going to see the last two topics in this subject, Maxwell Management 2. And the next topic is we are finished until 13.1. Today we are going to see about 13.2 and 13.3. 13.2 is about partial derivatives. It's just a continuation of the previous chapters only. So if you have some doubts, please go through the previous presentation or also go through our initial beginning topics and refer the formulas for the differentiation, integration, and so that this will be very much helpful. And this is about the partial derivatives. The formula is f of a by a comma b is equal to limit h tends to 0 into a plus h comma b minus f of ab comma divided by h. We don't use the formula directly, but we use our differentiation skills. Let's directly solve the questions. Question number 1, page 673. F of x comma y is equal to 2x square plus 3xy plus 4y square plus 5x plus 6y minus 7. So what we have to do, we have to differentiate this question or this function for x and also for y. Listen carefully, because it's a combined function. In the same equation we have x function and also we have y function. You see, if we have a y function, we have y function, x function. It is together there. X is there and y also there. So what we should do, first differentiate for x, that means fx comma y, by keeping y as constant, and the second differentiate y by keeping x as constant. It's quite easy. Just let's try to solve first one. Fx x comma y, that means differentiate this function in terms of x by keeping y constant, which is equal to 2x square. We know that how to solve 2x square, 4x. So the formula is x power n minus 1. So 2 is a constant, keep down, and x square n into x power n minus 1. N is 2 value, therefore I keep it front, x power n minus 1, 2 minus 1, which is 1. Therefore this is the function 4x plus in 3xy, here we have an x. When we differentiate x, their value is 1. Y we just write as it is. This is a constant. But here the number constant will get 0, but the y function will remain the same. Plus 4y square. If you look here we are differentiating with respect to x. There is no x term. Therefore, this will become automatically 0 because there is no differentiation function is there. Plus 5x. 5x, if you differentiate 5x, it will be 5. 6y, there is no differentiation on 0. Constant, it is 0. Therefore, the answer will be 4x plus 3y plus 5. Now, we have differentiated this function in terms of x. Now, we do the same thing in terms of y by keeping x as constant. So, fy of x comma y is equal to first term 2x square. There is no y function, therefore automatically this becomes 0. Here we have 3xy. Here we are differentiating in terms of y, therefore this will become 1 and 3x, write the same, plus y, 4y square will be 8y, plus 5x, there is no differentiation of 0, 6y, it will become 6, and 7, it is 0. That's the remaining function. So every question what we do, we differentiate in terms of x and also differentiate in terms of y. The second question is question number 3, page 673. F of x comma y is equal to 2y plus 1. The first one, differentiate in terms of x. So when I try to differentiate here, we don't have a differentiate function, therefore they become 0. Here it's a constant, that also becomes 0. So first differentiation with respect to x will be 0. Now the differentiation with respect to y. Here we have 2y. When you differentiate 2y, it will become 2 into 1 plus 1 is 0. That's this answer. The third one, 5. Question number 5. G of x comma y is equal to 3x power 4y plus 2xy square minus 5xy plus 8x minus 9y. Do the same thing. Differentiate with respect to x and differentiate with respect to y. First, with terms of x. G x of x comma y. That means we are differentiating this function, this equation in terms of x. 3 constant, x power 4. When you differentiate x power 4, it will be 4x cube. Therefore, 3 into 4, 12. 12x cube, and the y remains the same. And here, y square remains the same. When you differentiate x, it will be 1. Therefore, 2y square minus, here y remains the same because we have a differentiation constant x. It will be 5y plus 8, and minus here there is no differentiation function, therefore it will be 0. And we combined everything, 12x cube y plus 2y square minus 5y plus 8. Now do the differentiation for the same function in terms of y. So here y When you do the differentiation for y, it will be 1. Therefore, 3x power 4 into 1. When you do the differentiation for y square, it is 2y. 2 multiplied by 2, 4. Therefore, 4xy minus 5x into 1. This no differentiation function y is available. Therefore, this will become 0. 9y will become 9. Therefore, the answer is 3x power 4 plus 4xy minus 5x minus 9. And the next question is, we have two more questions in this section. Question number 7, page 673. G of p comma q is equal to square root of pq. So now with the square root, we cannot differentiate or integrate. So what we have done, remove the square root by taking power, pq power 1 by 2. Now differentiate with respect to p and differentiate with respect to q. The first one with respect to p. When we do a differentiation with respect to p, this 1 by 2 will come to the front. 1 by 2 into pq power 1 by 2 minus 1 multiplied by q. Q remains same, but the p will become the power 1 by 2 minus 1. When we simplify it, 1 by 2 pq power minus 1 by 2 into q. This minus 1 by 2 you can keep it down, it will be plus 1 by 2, and then 1 by 2 we can rewritten in terms of square root 1 by 2 into q divided by pq. Now we have to differentiate in terms of q. Therefore, g of q into p comma q is equal to 1 by 2, the same. pq the whole power 1 by 2 minus 1, but here instead of q in this area it will become p because we are differentiating in terms of q. So when we simplify the same way, we'll get p divided by 2 multiplied by square root of pq. The last question in this section is z e power x 5xy. So dou z divided by dou x. What do you mean by dou? This one, it looks like 2. Actually, this is called partial derivative function. Dou z divided by dou x, and then we have done dou z divided by dou y because we have two functions. Now, first one, we have to differentiate in terms of x. This is equal to e power 5xy, and then do the differentiation of 5xy. Y will be remains the same. Differentiation of x will become 1. Therefore, it will be 5y. 5y into e power 5xy. And when you do the differentiation of z, dou z divided by dou y, e power 5xy remains the same, and do the differentiation for 5x will become 5 into x. Y, it's 1. Therefore, 5x into e power 5xy. So that's all about this section. Partial differentiation, partial derivatives. And now we have to look into the applications of partial derivatives. Here we have just 2-3 questions. Let's continue the same topic. Partial applications. That's the last topic. Applications of partial derivative. Question number 1. C is equal to 7x plus 0.3y square plus 2y plus 900. Dou c by dou y. Here x equal to 20, y is equal to 30. They ask us to find dou c divided by dou y. It's called dou. Dou c divided by dou y. Differentiate in terms of y by keeping x constant. Now, dou c by dou y is equal to here 7x. There is no y is available. Therefore, it will become 0. Here minus 3y square. Differentiate it 2 into y. So minus 3 2y plus 2y become 2, and this constant becomes 0. Therefore, 0.6y plus 2. Now we have to consider x equal to 20 and y is equal to 30. So we don't have this function, we don't have x function, therefore no worries. But we have y function, which is 30. When you substitute 30, it will become finally 20. Use a multiple calculator and find the final answer. And the next one, p is equal to 15lk minus 3l square plus 5k square plus 500. So we have two functions l and k. Now we have to differentiate with respect to L and with respect to K. First one, dou P divided by dou K by keeping L as constant. So here we have a K. This will become 1. Therefore, 15L minus. Here L is available but no K. Therefore, this becomes 0. Here K is available. Therefore, yes, 2 into K. Constant is 0. Therefore, 15L plus 10K. And this is the function differentiator, partial derivative function with respect of partial derivative function with respect to k. Now partial derivative function with respect of L. L is equal to, here we have a L. Therefore this will become 1. K remains the same. Derivative of this function is same, and minus 6 L square. This here only k, therefore 0 plus 0. The final function is this one. So these are the two applications. So two different applications of partial derivative. One more application is this one. We have a condition also. First let me explain the condition, then I will solve the question. Actually this is a condition. We have two conditions. One is less than 0, the other one is greater than 0. If it is less than 0, these products are called complementary products. If it is less than 0, These products are called complementary product. Now you may have a question, what about if it is greater than 0? If it is greater than 0, dou QA divided by dou PB is greater than 0, dou QB divided by dou PA is greater than 0, then it is called competitive products. Listen carefully. If it is less, then complementary. If it is greater, then it is competitive. Suppose if you have doubt, you can refer the book also, page number 677. In page 677, our prescribed book, our like reference book, it clearly gives, if it is less than 0, it's called, the products are complementary. If it is greater than 0, it's called competitive. Now, how to find? The question will be very clearly, they'll ask, find if the products are complementary or competitive. The question number 7, they ask us very clearly, if QA and QB are demand function, then you find if it is complementary or competitive. This function is given, QA is given and QB also given. Therefore, QA I'm writing in terms of without a square root. Therefore, 100 PA power minus 1. This I have written in the numerator, and square root of PB I written in the numerator, PB power minus 1 by 2. And QB is 500 PB power minus 1 and cube root of minus 1 by 3. Now these two functions are written in standard format to do the differentiation derivative. So now how to find the partial derivative? Dou QA divided by dou PA. If you look here, I have done 4 different derivatives, partial derivative function. QA divided by PA, QA divided by PB, PA and PB. Then QB divided by PA and QB divided by PB, A, B, B, and also in the denominator PA, PB, PA and PB. So these are the 4 functions we have to find, and from that we just consider the 2 functions, dou QA divided by dou QB and dou QB divided by dou QA. We just have a look on it and then we'll find it. First, dou QA divided by dou PA. That means what? Find the differentiation of QA in terms of PA. Therefore 100, therefore it is PA is available, PA power minus 1, bring it to the front, minus 1, the PA power n minus 1, minus 1, minus 1, minus 2, and write the same term as it is, which is equal to minus 100 divided by PA square into PB power 1 by 2. That is done. Now do the differentiation of this function in terms of PB. In terms of PB, here PB is minus 1 by 2, power minus 1 by 2. Therefore 100 minus 1 by 2, write the same for the first function, actually QA function. Differentiate this function alone first. Therefore PA power minus 1 and the PB power minus 3 by 2. How come this minus 3 by 2? N minus 1. Here n is minus 1 by 2, minus 1, which is minus 3 by 2, which is equal to, these two will get cancelled. Therefore minus 50 divided by PA into PB power plus 3 by 2. We have finished 2. We need to do 2 more. We have to differentiate this function in terms of PA and PB. QB function, dou QB divided by dou PA. So what will come, which is equal to 500, and then we are differentiating, we are finding the derivative in terms of PA. Therefore this have to be derivative, and this one write the same, PB power minus 1, PA power minus 1 by 3. Therefore minus 1 by 3 into PA power minus 1 by 3 minus 1, which is minus 4 by 3. So I have simplified, minus 500 divided by 3 PB into 3 PA the whole power 4 by 3. And do the differentiation of this function in terms of PB. Dou QB divided by dou PB is equal to 500, write the same, and this is the PB function, power minus 1, therefore n into a power n minus 1. Here n is minus 1, PB power minus 1 minus 2, and write this term as it is, minus 500 divided by PB square into PA power 1 by 3. Now we have to look into this function, dou QA divided by dou PB and dou QB divided by dou PA. So first one, dou QA divided by dou PB, dou QA divided by dou PB, this function. If you look here, its minus function is there. So it's obvious, if I put 1 here, it will be minus only. Therefore no other change, it remains the same. And also when I look, dou QB divided by dou PB, dou QB divided by dou PA, dou QB divided by dou PA. In this function also here we have a minus. So both are very clearly states that both are less than 0. Therefore when we write the condition, dou QA divided by dou PB is less than 0 and dou QB divided by dou PA is less than 0. Therefore these products are complementary function or complementary products. or complementary products. If it is greater than 0, then it is competitive products. So please remember about it. We have a couple more questions in the book. Please practice some more question, 1 or 2 question. Question number 6 is available. That also the same topic. You can try it out for a practice question number 6, and check whether it is complementary or competitive, and it will be easy for you. Okay, good luck. Please study well. We have almost done all the topics. Whatever topics we covered, please study well. And the portion for the exam is already available in the Blackboard. Please go through the announcement and also study all the topic. Good luck, gentlemen.